And finally, moving on to question 7 here, we have a question on the geometric distribution. So, for this question here, for part A, we're just asked to find two probabilities. So what we've got here in this question is a spinner, which can land on either red or it can land on blue. So when it's spun, the probability is a third of it landing on blue. So what that means straight away is we can write down the probability of red will be 2/3. So the probability of R is 2/3. If the probability of blue is 1/3. Okay. So part A just asks us to find the probability that the random variable B, so that's the number of spins when the spinner first lands on blue, so that's how we know it's geometric, because it's going to be a number of failures before it is a success. So it's how many times does it have to, what's the probability where it lands on blue on the 4th attempt. So if we write this down, the probability that B is equal to 4. Well, for this one here now, remember, what it's doing is it's landing on the 4th attempt, so what that means is it's a failure, followed by a failure, followed by a failure, followed by a success. Okay, that's when it lands on blue. Well, I've wrote them as F and S, but my failure would be my red. We don't want red, that's a failure, and my success would be blue, that's when it lands on the one we want. So, that's failure, followed by failure, followed by failure. So that's 2/3 times 2/3 times 2/3. Well, we can just simply write that in index notation. That'll be 2/3 to the power of 3. And then the success is 1/3. So it's 2/3 cubed times 1/3. Well, 2 cubed times 1, so that'll be 2 cubed. And then finally, 3 cubed times 3, so that's 3 to the power of 4. And then if we work this out, 2 cubed is 8, and then 3 to the 4 will be 81. And there we have it, 8/81. So that's the first part. And then for the next one, so II, we have to find the probability that B is less than or equal to 5. Now, okay, so again, this one's pretty straightforward. Just got to be aware of the fact that when it's less than or equal to, we do 1 minus, okay, 1 minus the probability that B is greater than 5. So, probably that B is greater than 5, well, that's just going to be 1 minus, okay, the probability that it's red, so that would be 2/3, so 2/3, and then we raise it to the power of how many times. So because it's 5 here, we raise it to the power of 5. Just plug this in on your calculator. You don't have to sit and work this out. It's not about the actual calculations, but you'll get 211/243. Okay, so that's the first two parts for A, fully complete. So let's have a look at part B now. We have to find the expectation of B squared. So part B, E of B squared. Okay, so the formula for the variance is as follows. So that the variance of B, which you should be very aware of now if you've studied further stats 1, so it's E of B squared minus the expectation of B all squared. So minus, put it in a bracket, B all squared. So that's how we work out the variance. Well, the expectation for B here is really easy. To work that out, all we do is we do 1, so it's 1 divided by the probability. Well, in this case, the probability of blue is 1/3, so it's going to be 1 divided by 1/3, which is just simply 3. Okay, so that's the expectation of B. Now, we need to work out the variance. So, variance, we'll just call it sigma squared, that will be 1 minus P all over P squared, where P is your probability again for blue, so this should be the sigma squared of B. Well, P is a third, so 1 minus a third divided by a third squared. 1 minus a third, that's 2/3. A third squared, 1/9. So this would give you 18/3, which would just simplify to 6. Okay, so we've got these little bits of information now. Now we can work out the expectation of B squared by just rearranging this. So we know E of B squared, well, that's equal to the variance of B plus this, right? We take this onto the other side, balance the equation, we're going to get it. So that's the variance of B plus the expectation of B all squared. Well, we know the variance of B, that's 6. The expectation of b is 3, so if we square that, plus 3 squared, so that's equal to 6 plus 9, which is just going to simply be 15. Okay, so that's how you find the expectation of b squared. So we've got through the first two parts. Finally, let's move on to part C. So we're given a bit of information to start the question. So they're playing the game with this spinner, so she must choose a colour, either red or blue. Steve will spin it repeatedly until the spinner first lands on the colour that Tamara has chosen, and the random variable x represents the number of the spin when this occurs. So if she chooses red, her score is e to the x, and if she chooses blue, her score is x squared. But notice this x squared here can be this e to the b squared here, okay? So we can use that, part B, to help us, but we're going to have to work out this e to the x part here for red. So how do we do that? Well, let's model it with another geometric distribution. So let's let r be the number of spins when it first lands on red. So we'll write that down. Let r be number of spins when it first lands on red. When first lands okay, so I'm going to model this now using R distributed geometrically with my probability being 2 over 3, okay, because that's the probability that it lands on red. So using this now, we need to work out the expectation of e to the x. So how do we do that? Well, that's just going to be the sum from x is equal to 1 to infinity of e to the x times, now this is by 1 over 3, so just like we would for the normal probabilities here, 1 over 3 x minus 1, and then you times it by the probability of success, so that'd be 2 over 3. So just like we did in part A here, where we did probability b being equal to 4 and so on, doing the same notation here, but we're putting it exact. We're using e to the x. So now we've got to evaluate this summation. So this looks tricky on paper, but if you're ever unsure how to calculate a summation, just write down a few terms and see if you can spot the pattern, what's going on. So let's just let x be equal to 1. So when x is 1, what do we get? Well, I'm going to get e to the 1, so that's just e times 1 over 3 to the 1 minus 1, so that's just going to be a third to the 0, so that's 1 times 2 over 3. So what I'm going to get is 2e over 3. Okay, so I get 2e over 3. Let's let x be equal to 2. So when x is equal to 2, what do I get? Well, I'm going to get e squared times 1 over 3 to the 2 minus 1, so that's a third. So at the minute I've got 2e squared over 3, and then times that by 2 over 3. So plugging that all together, I'm going to get 2e squared over 9. And then finally, let x be equal to 3. So you might have already spotted the pattern, but if I do one more, hopefully it'll make it extremely clear what the pattern is. So that's going to be e cubed times a third x minus 1, so that'll be a third squared. So we've got e cubed over 9 at the minute, and then we times that by 2 over 3. So I'm going to get 2e cubed all over 27. Okay, so can you spot the pattern here? Get me to each term. Well, all I've got to do is times this by e over 3, right? If I times that by e over 3, I get 2e squared over 9. Times this by e over 3, I get this. So what I've actually got here is my geometric series, obviously, but it's going to be an infinite geometric series, right? I can work this out and I can actually evaluate it. So if I just do it over here to evaluate it, you sum to infinity, that's equal to a over 1 minus r, where a is your first term and r is your common ratio. So my first term is when x is 1, so that's 2e over 3. So 2e over 3 divided by 1 minus r. So 1 minus my common ratio, so 1 minus e over 3. Now, all you've got to do is actually evaluate this, okay? So if you evaluate this, what do you get? Well, you'll get 19.29a, so on and so on, okay? So that is now my expectation for e to the x. And we know the expectation for x squared, that is what we just worked out in part B. So what was that? I can't remember what I wrote down. That was 15. There we go. So we want the one that gives us a larger number on average. So that will be E, the expectation of e to the x. So therefore, Tamara should choose red. So therefore, Tamara should choose red because it's got a higher expectation. And there we have it. So that's the end of this Further Stats 1 paper. Be sure to subscribe if you're new around here. I'm going to be going through all the new A-Level Further Maths papers and revision content.